Hi everyone, this is Yiming from Penn State. Today I will present our paper on news timeline summarization. This is joint work with the Washington Post, one of the leading newspapers in the US. Nowadays, the internet has become a primary source of news and information for many people, but probably because it's too good at delivering information, people could easily be buried in the information flood and lose track of the occurring events. Fortunately, news timeline, which summarizes each event with primary messages in a chronological order, comes to help readers understand the evolution of news events. And here, we give two examples of how real news timelines look like. So first of all, let's talk about what is news timeline summarization. To generate a news timeline, journalists usually use an event query with an event duration to get a corpus of related news articles, which consists of publication date and sentences. Then we can generate a series of dated summaries from the related news articles as timelines. In this paper, we use extractive text summarization, which directly borrows sentences from articles to generate text summaries. Specifically, our input will be a corpus of related news articles, and the output will be a few dated summaries in chronological order. Note that there is another category of text summarization technologies called abstractive summarization, which generates text sentences from words, but the generated sentences cannot guarantee the reliability. So we choose the extractive text summarization method to avoid fake news generation. To evaluate machine-generated timelines, we use the human-generated timelines and ground truth. There are two widely used benchmark datasets containing 41 journalist-generated timelines from 13 topics. All timelines are collected from mainstream news media, such as CNN and BBC. For each timeline, it includes one ground truth summary and one corresponding news corpus, which contains thousands of articles in average. However, majority of existing methods focus only on quality of generated timelines and ignore the generation speed. For example, we present the runtime of two state-of-the-art approaches over corpus size. ASMDS and TLS constraints are the two state-of-the-art methods that using submodule framework. As we can see, these two methods scale very poorly. Faster generation means we can deliver more news timelines to the readers. In addition, to find an optimal compression rate, journalists may tune the compression parameters iteratively, which also requires fast generation. Interestingly, although news timelines are composed of both salient date and daily summaries, existing studies mainly focus on modeling relationships among articles' context while paying less attention to date selection. For example, the original evaluation for timeline summarization is simply ignoring date selection and concatenating all daily summaries together for ROC score calculation. ROC scores are measured by the n-gram overlaps between the reference summary and the generated summary. As shown here, ROC scores are measured by the overlap of bigram. Since there is no date evaluation in ROC scores, to emphasize the role of date selection, one recent work proposed to weight ROC scores by date differences. For example, for each generated summaries, we can find the closest reference summary and calculate the ROC score between them, and then weight it by the date difference. In this way, timelines with more accurate date selection get higher scores. Similarly, the role of date selection is also overlooked in the generation process. Considering the date selection have been overlooked, we revisited the date selection in this paper and proposed to divide the summarization task by date. Here we present the framework of our two-stage news timeline summarization method. We call it Wilson. In first stage, we explicitly select salient date from news articles, and then we do daily summarization for each salient date. Local summarization could ignore contextual correlation across the dates, so we include a post-process to reduce the redundancy. So the first step is how to select salient dates. To rank date, we build a date reference graph and use PageRank to select the most salient dates. The date reference is defined by the sentences that published on date 1 and mentioned date 2. For example, we showed a few date references in this figure. It shows a few sentences that published on January 25th and mentioned the February 11th in the past year. The references can be viewed as the important signals from the editors, indicating important dates and events. To build the graph, we also need the edge weights. So we experimented with 4 edge weights, including the number of sentences and the temporal distance between the publication date and the reference date. Generally, all 4 edge weight yield comparable results, which can be found in the paper. But we indeed observed an interesting phenomenon that past events are mostly frequently referred because they existed longer than new events. For example, the right figure we showed the selected date distribution for different methods. As it is shown, some module framework actually tend to select a large amount of past events. So we propose to adjust the probability to compensate the recent dates, which gives us a better alignment with the ground truth timeline, noticing the red one and the yellow one. And it also leads to a better performance in daily summarization. Having selected the most salient dates, we divided the whole timeline summarization task into multiple daily summarization tasks. For daily summarization, basically we can use arbitrary extractive text summarization algorithms. For simplicity, we use the classic text rank algorithm, which is similar to the date selection, and use the page rank to select the most important sentences. And we include a post-process procedure to further refine our daily summaries. Here we show the comparison between our proposed method with the 2 state-of-the-art methods in all ROC scores. Concat means we ignore the date selection and only compare the ROC scores with concatenating daily summaries, while the other 2 actually are both time-sensitive ROC scores. Note that as we optimize the date selection directly, our gains actually are even higher in time-sensitive ROC score measurement. As shown, our method significantly reduced the generation speed as expected. Comparison with other methods can be found in the paper. In addition to ROC scores, we also consult professional journalists at the Washington Post to manually evaluate the quality of machine-generated news timelines. So we sampled 10 timelines from 6 different topics, which consists of about 800 daily summaries from about 500 distinct dates. For each timeline, we present the human-generated ground truth timeline to the journalists and randomly order the 3 machine-generated timelines. And the journalists are expected to rank the 3 machine-generated timelines. As shown, our method is actually comparable with or even better than the state-of-the-art approaches. But note that the generation speed of our approach is way faster. Finally, we use our approach to build a real-time news timeline summarization system on an industry-level news corpus from the Washington Post. We're pre-processing a 4-year news corpus over 1 million news articles and use the search engine to index all the temporally tagged and tokenized sentences. Giving event keywords and expected event duration, the system can retrieve the relevant content and use our method to generate news timelines in real time. For example, here we give an example of how we can generate the timeline about how US and North Korea reached the summit in 2018. We set the keyword to Trump, North Korea, Kim summit, United States, and the event duration to the first half of 2018. We can generate the timelines here. Compared with the journalist created timeline, which is in this link, we highlighted the main coverage between our output and the manually generated ones in blue. As shown, our system gives very promising results. So the take-home message here is that even if this selection is overlooked in the existing news timeline summarization methods, it's very important. As shown, with accurate date selection, we can generate high-quality news timelines without considering the temporal correlation in text summarization. And also leveraging the explicit date selection, we can divide the whole timeline summarization task into multiple smaller local daily summarization tasks for efficiency. And also we signaled future directions for news timeline summarization. That is, we need a better salient date selection, and we also need to explore the temporal correlation in text summarization for better daily summaries. Thank you very much.